We will now discuss the solution of a problem that appeared in the CSIR National Eligibility Test held in December 2023. The problem is related to the concepts of the eigenvalues from the section Linear Algebra. This question is from the part B, which is a multiple choice question, and bearing the question ID 704028, and it carries 3 marks. The given question is, let A is equal to A suffix I comma j be n by n real matrix with Aij is equal to the product I into j for all 1 less than or equal to I comma j less than or equal to n. If n is greater than or equal to 3, which of the following is an eigenvalue of A? And we are given 4 options. Right. Let's now discuss the solution of the problem in detail. We have the matrix A, Aij, an n by n real matrix with Aij is equal to the product I multiplied by j for all 1 less than or equal to I comma j less than or equal to n. Now let's write down the entries of A and write down the matrix A. The matrix A is equal to 1 into 1, so I into j, 1 into 2, 1 into 3, etc. 1 into n. So like that, n into 1, n into 2, n into 3, n into n. Right. So multiply and write this as 1, 2, 3, n, 2 square, 6, 2n, 3, 6, 3 square, etc. 3n, and the nth row will be n, 2n, 3n, and n square. Right. So what is that we want to talk about? We want to talk about an eigenvalue of this A. Right. So let lambda I, 1 less than or equal to I less than or equal to n, be the eigenvalues of A. Then the sum of all the eigenvalues, sigma lambda I, will be the sum of the diagonal entries, that is the trace of A. So sigma I is equal to 1 to n lambda I, the sum of the eigenvalues, is equal to the trace of the matrix A, and that is equal to the sum of the diagonal entries in the matrix A, that is 1 square plus 2 square plus 3 square plus n square. We know the sum of the squares of the first n natural numbers is n into n plus 1 into 2n plus 1 by 6, and we want to show one of the eigenvalues is precisely n into n plus 1 into 2n plus 1 by 6. We continue the discussion in the next slide. We have the matrix A and make an observation. The entries in the second row are precisely 2 times the entries of the first row. And so also the third one is 3 times of the first row. The nth row is n times of that one. So now our goal is to make this A into an echelon form. So we want to reduce it by means of the elementary row operations. So to make this 2, 1 position 0, so we make R2 is R2 minus 2 times R1. To make this as 0, R3 is R3 minus 3 times R1. In a similar fashion, for the nth row, it will be Rn is Rn minus n times R1. So make such a kind of elementary row transformations. So R2 is R2 minus 2R1, R3 is R3 minus 3R1, etc. Rn is Rn minus n times R1. Then you will see all the rows, second row, third row and nth row, they will all become 0. Right. So this is equivalent to 1, 2, 3, n, and all rows are zeros. Right. So this is now ready-made. It is in a row-reduced echelon form. The rank of A is the number of non-zero rows in the row-reduced echelon form. Therefore, rank of A is 1 because there is only one non-zero row in this echelon form. So rank of A is 1. The order of the matrix A is n, and 1 is less than n. Therefore, determinant of A is 0. Determinant of A is 0 means 0 is an eigenvalue of A. Let us say that eigenvalue is lambda 1. Lambda 1 is equal to 0. Now, we now use rank-nullity theorem for this matrix. Rank of A plus nullity of A is equal to the number of the order of the square matrix, that is n. Now, we want nullity of A is equal to n minus rank of A, but the rank of A is 1, it will be n minus 1. And what is nullity of A? The dimension of the null space of A, that is n minus 1. Now, in this null space of A, if I take lambda 1 is equal to 0, this is the null space of A minus lambda 1 it amounts to, because lambda 1 is 0. So, this will imply the dimension of the null space of A minus lambda 1 I is equal to n minus 1, because lambda 1 is 0. I am not saying whenever it is the dimension of null space of A, I am not saying this dimension of null space of A is equal to the dimension of null space of A minus lambda 1 I for some lambda 1. No, because lambda 1 happens to be 0, this is same as this one. That's what I am saying. So, what is the dimension of the null space of A minus lambda 1 I? It is this is the geometric multiplicity of the eigenvalue lambda 1 is equal to 0. That is equal to n minus 1. And we know the relationship between the algebraic multiplicity and the geometric multiplicity. What is that? The algebraic multiplicity of lambda 1 is equal to 0 is always greater than or equal to the geometric mean of lambda 1 is equal to 0. Therefore, AM of lambda 1 is equal to 0 is greater than or equal to n minus 1. So, we have two possibilities. One is it is either n or n minus 1. So, the AM of lambda 1 is equal to 0 is n, or the AM of lambda 1 is equal to 0 is n minus 1. We continue in the next slide. Yes. So, suppose that the AM of lambda 1 is equal to 0 is n. That means lambda 1 is equal to 0 is repeated n times. That means lambda 1 is equal to lambda 2 is equal to etc. Lambda n is equal to 0. Then the sigma I is equal to 1 to n lambda I is n into n plus 1 into 2n plus 1 by 6. We have already noted. And each eigenvalue is 0. Therefore, the sum of the eigenvalues is 0 is equal to n into n plus 1 into 2n plus 1 by 6. This will imply n is equal to 0, which is a contradiction. Right? So, this is not possible. That means the AM of lambda is equal to 0 is equal to n is not possible. Therefore, the AM of lambda 1 is equal to 0 is n minus 1. That means lambda 1 is equal to 0 is repeated n minus 1 times. That means, let us say lambda 1 is equal to lambda 2 is equal to lambda n minus 1 is equal to 0. Let us say this. Then the lambda n will be not equal to 0, because lambda 1 is equal to 0 is repeated n minus 1 times. This is a repetition of n minus 1 times, and the nth eigenvalue lambda n not equal to 0. Let's go back. Sigma I is equal to 1 to n lambda I is equal to n into n plus 1 into 2n plus 1 by 6, and the sum of the first n minus 1 eigenvalues is 0 plus the nth eigenvalue lambda n is equal to n into n plus 1 into 2n plus 1 by 6. So this tells you lambda n is equal to n into n plus 1 into 2n plus 1 by 6. This tells you one of the eigenvalues of the matrix A is n into n plus 1 into 2n plus 1 by 6. So this is an eigenvalue of A. Let's look at our options, and our answer that n into n plus 1 into 2n plus 1 by 6 is an eigenvalue of A appears against option 4. Therefore, the answer to this question is option 4. That is the detailed discussion of the solution of the given problem related to the eigenvalues of a given matrix from the section Linear Algebra. I am sure that you have understood the solution of this problem. I have been doing the videos for the benefit of my students who are pursuing CSIR NET exam, IIT JEE main exam, TS set, AP set, etc. examinations. And I am sure that you like my videos. If you like the content and the method of explanation and the type of questions that I do, please like, share and subscribe my channel. I wish you all the best. Thank you.